So this example is very similar to number 13 in section 12.5. In fact, when I clicked on number 13 and I said view an example, this is what they gave me. But then the steps that they showed, I thought that they were way too complicated. I believe there's a much easier way to do it. So first of all, notice that these have the same directional vector. That means that they're going in the same direction, and these two numbers are different. That means that they're parallel. So in order to ask for the distance, they have to be parallel. That way, no matter where you measure the distance, it's always going to be the same. Okay, so they're parallel. Now what I could do is I could find a point on this plane. The easiest way to do that, I believe, is put x equal to 0, put z equal to 0, then it's going to say 4y equals 12, so that means that y equals 3. So if I call this plane number 1, then on plane number 1 is the point 0, 3, 0. All right, now in a previous section, I had covered this, the distance from a point to a plane. And if you're going to use this formula, you need to have the plane set equal to 0. So you need to subtract whatever the constant was so that it's equal to 0. Then you just take the numbers for x, y, and z, you plug them into the plane. That's going to give you a number. It could be negative, so you'll need to take the absolute value. And then for the plane's directional vector, you find the length of it, you divide by that, and that's going to be the distance. Okay, so I have a point, and this point is on plane 1, it's not on plane 2. So I can now use that formula that I just showed you and find the distance from this point to that plane. So I need to plug in the numbers for x, y, and z. So that would be 3 times 0 plus 4 times 3 plus 5 times 0. And like I said, this needs to be moved to the other side. So subtract an 18. So it's possible that that's a negative, and we talk about distances being positive, so take the absolute value of that. And then divide by the square root, and now you just find the length of this vector, 3, 4, 5. So square root of 3 squared plus 4 squared plus 5 squared. So this is going to be 0, that's 0. So right here we have 12 minus 18. That's going to be a negative 6, but because of the absolute value, that's going to be 6. And this is going to be 9 plus 16, which is 25, plus another 25. So that means we're taking the square root of 50. All right, almost done. Then I need to simplify this. So this would be 25 times 2, so that's 5 radical 2. And then if they ask you to rationalize, multiply top and bottom by square root of 2, and what's the final answer? So this radical 2 is going to stay there. This is going to be a 2, which could then reduce that to make it a 3 radical 2 over 5. All right, so that is the answer. Now, what I'm also interested in is why this formula? How does that work? Where does it come from? Is there an easier way to do it, or is there a better way to understand it? That's the second half of this video. Okay, so let's say that you have a plane. Here's the plane. And you have a point that's not on it, so that's going to be point P. And you need to find the distance from this point to the plane. So of course you would go straight down to find the shortest distance. So by distance, what's meant is, what's the shortest distance? Which means that this needs to be perpendicular to the plane. So what's that distance? Well, with the plane, whatever is sitting in front of x, y, and z, that's going to tell you the normal vector, which is also perpendicular. Well, if you know a point and you know which direction you're supposed to go, then you can find the line that goes through there. So I could then find the line that goes through P and goes the same direction that N goes. And then once I find this red line, I can find out where it intersects the plane. Let's say that's point Q. And then from the very first section, just use the distance formula for the distance between 2 points. So what I'm going to do is redo the problem that I just did. Hopefully, I'm going to get the same answer, but I'm going to do it in a different way that instead of using this, I'm going to see where that comes from. All right. So it's the same question. And I even have that point P. Okay, so now find the equation of the line. So the line is going to be x equals, y equals, and z equals. So it has to go in the same direction as this. So it's going to be 3t, 4t, 5t. And then it needs to be plus this point right here. So that would be 0 plus 3 and 0. Okay, that is this red line that I just showed you, this dotted red line. I already found that red line. Now I need to see where this red line intersects with the plane so that I could find this point Q. Well, that means all I need to do is plug in this for x, this for y, and this for z. And then I could solve for t. So it's going to be 3 times x, or 3 times 3t, plus 4 times y, so 4t plus 3, and then 5 times 5t, and then that equals 18. Notice right here what this is doing is saying for the first component of the vector, you need to square it. For the second component, you need to square it. For the next one, you need to square it, and you need to add those up. That sounds very similar to this part right here. But now I know why that is. So this is going to be 9t plus, and then 4t, whoops, I forgot to square it. 16t plus 12 plus 25t. And that equals 18. So this is 25t and another 25t, so that's 50t. And then subtract 12 from both sides, so we'd have 18 minus 12 is 6. And what did we end up with right here? A 12 minus an 18, but then we took the absolute value of it, so we got a 6. Okay, so t is going to be 6 divided by 50, or I could reduce that. It's going to be 3 divided by 25. Now this is the time when the two intersect. To find the actual point, I need to plug that in right there. So on my picture just a moment ago, I'm now finding the point Q. So the point Q is going to be, let's see, plug in what we just got, 3 divided by 25 right here. So the first component is going to be 3 times this, so that's going to be 9 over 25. Then it's going to be 4 times it, so that's going to be 12 over 25, and then plus this extra 3. And then the last one will be 15 over 25. Okay, now find the distance from P to Q. So P was that original point, this one right here, I called it P1. So find the distance between these 2 points. All right, so the distance formula is going to be, it is the square root, and then you take this minus this and square it. So that's going to be whatever 9 over 25 squared is. Then subtract these, which is actually going to cancel out the 3's, and then it's going to be plus 12 25ths gets squared. And then subtract these, so that's going to be 15 25ths gets squared. So how much is that? So I'll do the square root in a second, but as far as the fractions, there is 9/25 squared plus 12/25 squared plus, oh, the glare on that's horrible today. Sorry about that. 15/25 squared. And then I'll change that to a fraction. And it says that it's 18/25. So that means I need the square root of 18/25. Well, for 18, that's 9 times 2. So that's going to be 3 radical 2 over 5. And doing it the other way, I got 3 radical 2 over 5. It's a magic trick.